So today we're going to look at points, lines, and planes, and you're going to have a lot of definitions. If I were you, every definition that you have today I would put on a flashcard, 3x5 note card, or use that flashcard app on your phone and study those before you do your homework tonight. So we're going to just go through a brief lesson, and the first part of the lesson we skipped 1-1. But I think that you can look at these things right here are called nets. And what they are, they're solids that have been cut and all the faces have been opened up. And so I just want you to try to determine, which I think you should easily be able to do, which of these nets belongs to which of these solids. So just draw a line that will connect a net to its solid. Whatever you think. Do that on your own. All right, so for the first one, does it belong to the first solid, the second solid, or the third solid? So does this net belong to which one of these? First, second, or third? Abby? The first one. And so these go together. This is called a square pyramid, and we'll get into that a whole lot later. And you can see the base of that is a square right here, and then all of these triangle sides here, they form up to this point, making it a pyramid. So it has one base, and that's the base is different from all the others. So what about this one? Looks kind of funny. What solid does that relate to? Does it relate to this first one or this second one? The second one. And so this goes to that one, and this is called a cylinder, which you should be familiar with from 8th grade. And it looks like a canned good. And cylinders have two bases, two round bases, and then the label that goes around that can actually looks like a rectangle. And then that must mean that this relates to that one. And then this one is a prism. And it happens to be a rectangular prism. Or maybe, oh, this one's a square prism. Well, it's a rectangular prism. It's got two bases right here that are different from all the other faces, and these are squares. And then this, you'll learn later, is a lateral area. And so that's really all that you missed in the first lesson, which is why I pretty much skipped it. And so we're going to start in this. We're prepping you to do proofs, and in this class you're just going to have to do some really basic proofs. You're not going to have to do a whole lot of difficult ones. And we're going to use something called a conjecture. And a conjecture is just a guess, a prediction. What do you think might be the case? And that's all that they've said here. And we use a lot of conjectures in geometry, but theorems actually take conjectures and turn them into and prove that that conjecture is true. And so looking at here, you're going to write, we're not going to do this one. I don't really care about those sentences. So this is where the meat of your lesson is, this whole box up top here. We're going to define all of these terms. You have a place where you're going to put the term itself, the definition, or the word, and we're going to put the definition over here on the left. And then you got a nice picture of what's going on, which is why I printed out these notes for you. And then this is the notation. You have to pay attention to details. This notation over here to the right is incredibly important. If you use this notation right here for a line segment, when we're talking about a ray, you're going to get it wrong. So your job today is to study the notation along with the picture, along with what that definition of that item is. And so on this particular one, you've got, what's this picture showing? What is that thing? What do you think it is? It's just a point. And so that's what we're going to define here as a point. And my handwriting on the iPad is even more horrible than it normally is. And so write really small on the left. We're going to define what that point is. So a point is a location with no size. And it's just defining a place in space. It doesn't have any size. It's just like a city, Phoenix versus Scottsdale. Phoenix is a much larger city than Scottsdale, but most maps will just show them as the same point, same size point. Some maps might show Phoenix as a bigger point than Scottsdale, but they're just indicating where Phoenix and Scottsdale are, so that point just indicates a location in space. The notation for a point is a capital letter, not a lowercase letter. Lowercase letters in geometry mean something completely different. So a capital versus a lowercase is important. Because look over here, isn't this a lowercase letter? And this lowercase letter is going to indicate what this whole item is, which happens to be a plane, but we'll talk about that in a minute. So what's this whole thing right here? What would you call that? If it's not a point, what is this? It contains a lot of points with two arrows on the end. A line, right? So this one's a line. And a line contains at least 2 points and extends in 2 opposite that says opposite, 2 opposite directions infinitely. So it contains at least 2 points, and you can see the 2 points on this line are A and B, named with capital letters, and extends in 2 opposite directions. So here's one direction, here's the other direction, infinitely. And so those arrows just indicate that it never ever ends. And then notice that the notation would be the 2 points that it's going through, and then it's got a little line above it. So you have to have an arrow on both ends to show that proper notation that it's a line. They could show more than 2 points on this line, so they could have put a third point here, I don't know, and called it C, if I can get that on the line, and called it C. And you could call that line CB, you could call that line BC, you could call it AC, you could call it CA. You just have to choose any 2 points that are on that line in whatever order you want to. So the order of, I'm going to erase that. The order of how you name these doesn't matter. So you could also name this right here BA within a line above that. Those mean the same thing. That's the same line. What else do you notice in this picture that we haven't talked about? What's missing that we haven't talked about? What about that right there? Have I discussed that yet? That's a lowercase cursive letter L. This is also another way to name a line. So there's 2 ways that you can name a line, with 2 points and a line above it, or just quite simply a lowercase L. This is not a point on the line. They're just calling that line L. And it always will be a lowercase cursive letter. So if you don't know cursive, you're going to have to learn it. So those are the 3 ways that you can actually write a line, or write the notation for a line. And then this whole thing right here includes 3 points And this is really a snapshot. It's almost like that wall, your desk, the floor. These are all parts of what's called a plane. A plane extends infinitely north, south, east, and west. So if you can imagine this wall in front of you that extends forever north, forever south, forever east, and forever west, a rectangle or a parallelogram or a square or some sort of quadrilateral is just a snapshot of what we call a plane. And so for this one, this is a plane, P-L-A-N-E. And it must have at least 3 points that are non-collinear, meaning collinear means that they're on the same line. So you want to have 3 points that are not on the same line. So if I had given you a picture that looked like this, but had that point C there again, this would not be a plane because all 3 points, A, the C that I had there originally, and B, would all be on the same line. It's not defining a plane because you can only see 2 directions. That third point that would not be on the line extends it and makes it go in 4 different directions. And so your definition is a flat surface extending in that's actually the word in. All directions infinitely. And planes are, the notation for a plane is a capital, this is supposed to be a cursive letter P, because they kind of look alike, so that's actually not a lowercase. So write yourself a note here that this is a capital cursive P. So planes are indicated with capital cursive letters. The other way that you can name a plane is with 3 points that are not on the same line. So we could name this plane just a, whoops, go back. Oh, now I can't take it away. Okay, so the other way I could name this plane is just by calling it A, B, C. Nothing above it, nothing in front of it, just 3 capital letters A, B, C. In whatever order I want to. It could be BCA, CAB, whatever order of those 3 points that are not on the same line is also another way to name that plane. What is the difference between this picture right here and this picture right here? What's the big difference between these 2? Yes? One of them stops. This one doesn't have any arrows, and this one has arrows. So this is called a line segment, and it's a part of a line. So this line right here contains line segment AB, and here is line segment AB pulled off of that line. And let's see if I can get a different color. So this is a line segment. And a line segment is part of a line. That has one endpoint. Oh, sorry, part of a line containing 2 endpoints. I knew that looked funny. And all points in between. So part of a line containing two endpoints and all points in between. So if there were any points in between A and B, it would contain those points. And there's actually an infinite number of points between A and B. You just don't see them. And note the difference in notation for these two. It just has a line segment above with no arrows. And again, just like this one, this line up here, I could name this line segment BA. The only difference is the line segment does not have a lower case cursive letter that you could call it, because it's not a line. So these are the only two options here. And then the difference between these two, you see point A, but what's happening here at point B? Does this line segment stop at point B? It's going infinitely in the direction through point B. So this is called a ray. A ray starts at one endpoint and goes infinitely in the direction through another point. And let's get an ugly orange. That works for me. So here's a ray. Notation for a ray is very picky. So let's define it first. It's, again, part of a line. That has one endpoint. And extends in one direction. This is the only notation that you can have for the ray. When you note a ray, this first letter right here has to be the starting point. So since it starts at point A and goes through point B, it has to be AB with an arrow on the right side. And it doesn't matter if we had this. Let me put black up here. If we had our ray going in this direction, and then this would have been point A, and this would have been point B. So it's just in the opposite direction. This ray would have been labeled, what's the starting point for this ray I just drew? Point A or point B? B. So we'd have to start our notation at B. It goes through A, but notice that I still put an arrow on the right-hand side of that notation. So the arrow notation above here does not necessarily go in the direction of the ray. But this notation is telling us, oh, that ray starts at B and goes through A. So I know it starts at B and goes through A, so it must be going to the left. And a ray can go in any direction in a circle, right? And so that's why you're just going to see a right-hand arrow over here. And these are two different rays. They're not the same thing. And that's going to be a question that they're going to try to trip you up with. And then this last thing right here are called opposite rays. Opposite rays actually form a straight line, forms just the line. They are two rays that share the same endpoint. And form a line. And so what endpoint do these two rays share? If I've got rays going in opposite directions, what endpoints must they share? C. So notice that they've got C, starting at C, going through A, that's this part of the ray right here, and starting at C, going through B, is the notation for that ray there. Now, the rays could have started at B and gone through either of these 2 points, but there's no point to the right of B. So you can't call those opposite rays until you put a point to the right of B. So C is the one that's in the middle, which makes it the starting point for both of those opposite rays. And then there's 3 other definitions I'd like you to write off here to the right. Give yourself a little bit of room over here. One that I've already talked about. One definition is collinear. They're going to use that a lot. Whoops, I need 2 L's in collinear. So collinear points would be points that lie in the same line. And then they're going to use something called coplanar. Coplanar. What do you think coplanar means? If things are coplanar. There you go. Thank you. So coplanar would be points and lines because planes contain both points and lines. So points and lines that lie in the same plane. And then the last definition, and then you'll be definitioned out, is space. And space is the set of all points in 3 dimensions. So I'm just going to put it here in 3D. So a set of all points in 3 dimensions. So this room is called a space. It's really volume. If I were to fill up this room with cotton balls, that's space. It's filling up space. Okay, so then let's look at and use some of these definitions. So I want you to draw a line from each item in column A to its description in column B, and they're using the picture to the right to help you with that. So work in your groups and try to figure out what goes with what based upon the definitions above. So I'm going to give you a couple of minutes to do that. Let me record those. So those of you watching the video, you missed the explanation of the answers to this, so you'll have to come talk to me if you don't get it. But, whoops. That back into place. 13 goes down here, and 14. What did BF go to? Oh yeah, it went down to here. And then plane DAE was it the same as AEH? Yeah. And then line Y is the same as the line through these two, and point A is the same as the intersection through those two. Okay? Let me erase these on the board. Alright, so we're almost done. Alright, so let's look at some postulates. And postulates are essentially a theorem that does not have a formal proof behind it. And these are things you want to put on a flashcard. These are things that are going to come up constantly, so you need to learn them. And if I were you, I would put on the front of my flashcard the if part of the statement, even if it's not an if-then form, and then the then part. So kind of cut your sentence in half here. And I'll cut it in half for you as we go through it. So for the first one, it says, through any 2 points, there's exactly one, and what's missing here is the word line. And so that's what goes here. So through any 2 points, there's exactly one line. There's no way you could draw a line any differently if you have 2 points. Everybody would draw the same line. And so I'll go ahead and just let you put that on a flashcard for right now. When we talk about if-then statements, then we'll get into that. But for right now, just put that on your flashcard and learn it. Through any 2 points, there's exactly one line. If 2 distinct lines intersect, what did we learn about 2 lines intersecting? 2 lines intersecting, what do you get? A point. All right? So then they intersect in exactly 1 point. And then postulate 1-3, if 2 distinct planes intersect, then they intersect in exactly 1, remember, 2 pages in a book, or the covers on a book, or the 2 walls in a room, what do they intersect as? What do you get? What's that whole thing? A line, right? So if 2 distinct planes intersect, then they intersect in exactly 1 line. And then finally, postulate 1-4, through any, and here's the key word, 3 non-collinear points. That means 3 points that are not on the same line. So anytime you have 3 points that are not on the same line, you get exactly 1 plane. And that's your definition of the plane. So learn those. All right, let's look at the third. I mean, if I were you, I'm not going to make you determine if it describes a postulate or undefined term, but I want you to know these. So these are just some more statements. A point indicates a location has no size. Isn't that a definition that we just had? Through any 2 points, there is exactly 1 line. That was that postulate that we just did. I don't care whether you know if it's a definition or a postulate. I just want you to know them. A line is represented by a straight path that has no thickness and extends in 2 opposite directions without end. Well, that's a little bit more detailed of a definition that I gave you for a line, but that's a definition. If 2 distinct planes intersect, then they intersect in exactly 1 line. That's that postulate we just went over. If 2 distinct lines intersect, then they intersect in exactly 1 point. Again, postulate we just went over. Through any 3 non-collinear points, there is exactly 1 plane. Technically, they're going to say that's a postulate. It's also based upon the definition of a plane. So again, I don't care if you know whether it's a postulate or definition, just know them. All right, look at problem 2. Here are some problems we're going to say. We're going to have you state some things. So they tell you, what's this notation here telling you? What kind of notation is that? Is that a line segment, or a ray? This is a ray. So they give you 2 rays. Ray EF and ray FE form a line. Now they're telling you that with this named as EF, that this ray starts at E and goes through F. This ray starts at F and goes through E. And so are they opposite rays? And explain. What's the definition of opposite rays that I gave you? Do you remember? Let's go ahead and put E and F on this line. Here's E and F. So the first ray, EF, means that it starts at E and it goes through F. So cover up this part right here. It starts at E and goes through F. The second ray starts at F and goes through E. Opposite rays have to have the same starting point. Do these rays have the same starting point here and here? No. So these are not opposite rays. And so these questions are trying to get you to that. Do ray EF and FE share an endpoint? The answer to that is no. Next question, do ray EF and ray FE form a line? The answer to that is yes, they do form a line. You can see it above there. Are the rays opposite rays? And the answer is no. And the reason is they do not share the same endpoint or the same starting point. So on this one, you're looking at the picture to the right. It says each surface of the box at the right represents part of a plane. They're just snapshots, those sides of the box. So you really have 6 planes that are all intersecting to form this box. And so circle the points that are on line BF or in one of the 2 planes. So they want to know what are the names of the 2 planes that intersect in BF. So let's find BF. Here's BF. That's the intersection of 2 planes. So I'm going to underline the points BF. So here's B and here's F rather than circle them. Because I want to circle the points that are all in the plane. So what points are in this plane right here? Because this plane right here contains BF, this front of the box. So don't we have to include A and E? A, E, B, and F are all in that plane. So circle A and E. And then on the other plane, right over here, this side of the box, B, F, G, and C, they all are in that one plane. So we're going to circle C and G. And here's their purpose. Circle another name for plane BFG. So look for BFG, trace from B to F to G, right? Isn't that this plane here? So BFG can be named with any of these 4 points that are in the plane, B, F, G, or C. So BFA, can I circle that one? Is A in that plane? Is A in this plane here? Yes or no? No. We're only looking for this plane here, we're only looking for the green and the blue. So what about BCD? No D, right? What about BCG? B, C, and G, that one works, right? What about CDH? C, nope, no D again. What about FGH? F, G, and H? No H, right? So this is the only one that works as another name to that plane. And then the last question says, name 2 planes that intersect in BF. Well, you can name them however you want to. Whatever 3 letters you want to over here, and whatever 3 letters over here. So, for instance, couldn't you do A, BF for the front plane, ABF? What else could I do? What's another name for this front plane right here? Using A, B, E, and F. What else could I have? A, B, and what? A, B, C's on the other plane. We want that front plane. E, right? What else? I could have BFE. I could have AFE. There's all ways to name that plane. What about the plane on the side? This one right here. What's one name? I heard it. C what? Say it loudly. Oh, BCG? Okay. BCG. That works, right? What else? C what? CGF. And these by all means are not all of them, because we could do quite a few combinations. What else? Any 3 combinations? FBC, perfect. And let's come up with one more. BFG. Okay? All right, so then let's look at the last page. And this last question says, what plane contains points L, M, and N? Shade the plane. So let's mark with our finger L, M, and N. If I combine, this one's a little bit more difficult. So I'm going to use this bigger box right here. So let's go ahead and connect L to M to N. If you imagined a box, because this one's going on to several different planes, this one is actually, if you imagine a box with another plane cutting diagonally through it, it's not actually a plane that you can see on here. The plane that they're looking for goes through N and P, and it touches here. It diagonally goes to the box looking like this. So think of a diagonal board that you tried to lay in that box. It was a little too big, and so it laid in there diagonally in the interior of that box. So you can have a plane that cuts through that you can't actually visually see. You have to kind of visualize that one. So that one's a little bit more difficult. What kind of shape is that thing that we just shaded? Is that a triangle or a rectangle? Triangle has how many sides? 3. So how many sides do we have on this green thing that we shaded? 1, 2, 3, 4, right? So isn't that a rectangle? And then the plane, again, you could name that plane in a multitude of ways. Any 3 points that involved N, M, L, and P. So you could do N, M, P. You could do M, L, P. You could do, I don't know, M, N, L, etc. There's a lot of different ones you could do. And then we're going to stop here for today.